Hello everybody, welcome into another lesson. First, let me apologize for no lesson yesterday because we had a major power outage in the town that I live in. The power was out for 11 hours, so that was a lot of fun, especially in freezing cold temps. But so far we're back on today. Hopefully it stays that way. But today's lesson, we're going to transition into talking about similar polygons and similar triangles. But first, this lesson and the next lesson, we are going to review ratios and proportions because they are very necessary to understand when dealing with similar polygons and similar triangles. So, let's talk about what ratios are. If you remember from algebra and before that, it's a quotient of two numbers, basically a fraction. You could see it written as a over b, where you have the first number in the numerator, second number in the denominator. You could also literally say a to b or a to b. That's how that's read. A colon b is read a to b, where the a would be your numerator, the b would be your denominator. An example here, we have 8 to 12. We got the ratio 8 to 12. You could also say literally 8 to 12, or 8/12, which would also be read 8 to 12. It's basically just a fancier way of saying a fraction. A ratio generally is given in what's called simplest form, meaning the numerator and denominator are reduced as much as they can be. So 8 to 12 would reduce to 2 to 3. That's what 8 to 12 would reduce to, is 2 to 3, by the time you factor out the common fours. So let's go ahead and do a few examples here. Let's see what we got. Let's see, so x equals 12, y equals 10, and z equals 24. Write the ratio in simplest form. So yes, this lesson and the next one will seem a lot like algebra all over again, but it's important for the fact that when we get into similar shapes, we need this. Okay, so the first problem we're going to do here is the ratio x to y. We have x to y, right? Well, if it's x to y, x is equal to 12, that means it's going to be 12 to your y value, which is 10. So the ratio is 12 to 10. Well, we want to simplify this. In other words, factor out common factors, which would obviously be 2. The ratio would reduce to 6 to 5. So the simplest form of the ratio of x to y in this case is going to be 6 to 5. Alright, what's the next one? This time we have z to x. So we have the ratio of z to x. Well, what's the value of z? That's 24, right? 24. And then to your value of x, which is 12. 24 to 12 is the ratio, which in simplest terms, in simplest form, would reduce to 2 to 1. So one thing that sets ratios apart from fractions, though, we actually do keep the denominator of 1. If we were just dealing with conventional fractions, you would ignore your denominator of 1 and only worry about the numerator. But when you're dealing with a ratio, you keep your denominator of 1. So the ratio is going to be 2 to 1 for z to x. Alright, there's a fun one. we have x plus y 2z. So we have the ratio of x plus y 2z. Well, this tells you here that x plus y is going to be your numerator. You could put parentheses around that if it helps you, 2z. And then let's deal with the x and y terms in the parentheses. X is 12 plus your y term of 10. So that's 12 plus 10 to your z term, which is equal to 24. So now we have 12 plus 10 to 24. Well, 12 plus 10, that's going to be 22 to 24, which 22 and 24 both have a common factor of 2, giving you the ratio of 11 to 12. So the answer for this problem is the ratio of this would be 11 to 12. All right. This changes form. We have the ratio of x all over x plus z. So we have the ratio of x to x plus z. Well, we're still going to plug in values here like we did before, just the ratio is written as a fraction this time. So x, of course, is 12. This will be written as 12 all over x again is 12 plus your z, which is 24. So this is in the ratio of 12 all over 12 plus 24, which equals 12 all over 36, which we know would reduce to a ratio of 1 to 3. So the ratio we're looking for in this case would be 1 to 3. All right, how about this one? Y plus z all over x minus y. That's a different one. So we have the ratio of y plus z all over x minus y. So let's put in our values here. Y is equal to 10 plus your z, which is 24. So this is 10 plus 24 all over your x, which is 12, minus your y value, which is 10. So we now have the ratio of 10 plus 24 to 12 minus 10, which would turn into the ratio of 34 to 2, which would reduce to 17 to 1. So the ratio we're looking for in this case would be 17 to 1. Again, even though 17 over 1 and 17 mean the same thing, if you're referring to a ratio as opposed to a general fraction, keep that denominator of 1. It's very important for ratios. All right, let's do a few geometric examples here. Let's tie this into geometry a little bit, which is really why you're here. Okay, so let's draw a nice parallelogram here. Parallelogram A, B, C, and D. All right, so we have parallelogram A, B, C, D. Angle A is 30 degrees. They give you the length of AB is 15. They give you the length of BC is 9. Well, what might help you before we proceed any further, since we're going to be doing some ratio problems, would it not help to fill out some missing information? Let's start with the sides. What do we know about sides of a parallelogram? That opposite sides are congruent, right? So that means CD would also have a length of 15, and then AD would also have a length of 9. So we figured out the lengths. We know about angles in parallelograms that opposite angles are congruent. So angle A is 30 degrees. Angle C, the opposite angle, would also be 30 degrees, right? Since opposite angles are congruent. Now if we look at angles B and D, angle B is a same side interior angle to both angle A and B. Angle B is the same side interior angle to both angle A and C. We know same side interior angles are supplementary. So 180 minus 30 is 150. So angle B would be worth 150 degrees. And then since opposite angles are congruent, angle D would be 150 degrees. Alright, I think we've solved for all the missing information. So now we can proceed to dealing with ratios of these problems. First is the ratio of AB to BC. We want to find the ratio of the length of AB to BC. So all we need to do now is put in their respective lengths. AB has a length of 15, right? BC has a length of 9. So it's in the ratio 15 to 9, but we need to get it into simplest form. Well, both 15 and 9 have a common factor of 3, so that would be in the ratio of 5 to 3. And that would be your answer. The ratio of AB to BC is 5 to 3. Okay, what's next? We have the ratio of AB to CD. So this time we have the ratio of side AB to side CD. Well, they both equal 15, right? It's going to be in the ratio of 15 to 15, which they both divide by 15, so the ratio in this case would be 1 to 1. So you would actually express the ratio as 1 to 1 for AB to CD. Alright, what's next? Oh, good one. The measure of angle C to the measure of angle D. So we have the ratio of the measure of angle C to the measure of angle D. Now I think it becomes obvious why we found the missing information, right? This is going to make our life a lot easier. Well, measure of angle C is what? 30, right? That's going to be 30 to the measure of angle D, which is 150. Well, both have a common factor of 30, so this will end up being in the ratio of 1 to 5. So the ratio of the measure of angle C to the measure of angle D is going to be 1 to 5. Alright, how about the measure of angle B to the measure of angle C? So this time we have the ratio of the measure of angle B to the ratio of the measure of angle C. Well, the measure of angle B happens to be 150, where the measure of angle C happens to be 30, so you have the ratio 150 to 30. Well, both of these divide by 30, which would give you the ratio of 5 to 1. And we should know that the ratio of 5 to 1 and 1 to 5 are two different ratios. They're polar opposites of each other. They're inverses of each other. So order does matter with fractions and ratios. That's switching the numerator and denominator around. So as we know, we get completely different numbers when we do that. Alright, what's next? Last one with this shape. This is a good one. AD to the perimeter of parallelogram ABCD. So this one's going to take a couple steps. We have the length of side AD in the ratio to the perimeter of the whole parallelogram ABCD. Well, what is the perimeter, if we remember? The perimeter is simply the distance around the shape on the outside. To get the perimeter, all you do is add up the length of the four sides together. So the perimeter, we'll work that out on the side. That's equal to 15 plus 15 plus 9 plus 9. Right? You're just going to add the four sides together, which means then you would end up getting 30 plus 18, which should really give you 48. So the perimeter of this parallelogram would be 48. So now that we found the perimeter, we know that AD has a length of 9 to your perimeter of ABCD, which was 48. So this is now in the ratio of 9 to 48. Well, how do we express that in simplest terms? Well, they both have a common factor of 3. This would be in the ratio of 3 to 16. So the ratio of AD to the perimeter of parallelogram ABCD would be in the ratio of 3 to 16. Now, I do have a few word problems here. I got a few word problems that I'm going to teach you today. They're fairly simple. They go hand in hand with this. So let's get into those real quick. Actually, before we do that, let's do a few algebra exercises. We have 3 exercises here where we're going to write the algebraic ratio in simplest form. So we have 3 algebraic ratios. We have 3a to 4ab. So we got the ratio of 3a to 4ab. Well, if we review from algebra, the only things that will cancel out are a. This would simply reduce to the ratio of 3 to 4b. And that would be the simplest form for this ratio. How about the next ratio? We have 2cd over 5c to the third. Okay, well, 2 and 5 we can't do anything with. D kind of stands on its own. There's no other D term besides in the numerator. But between the numerator and denominator, you have a c in the numerator, which is c to the first, and then a c to the third in denominator. Well, since the greater power is in the denominator, we just subtract the power of the numerator from it. This will all end up in the ratio of 2d to 5 over c to the second. That would end up being the ratio of 2cd to 5c to the third would reduce to the ratio of 2d to 5c to the second. I got one more problem like this. This should be easy. We have 3 times the quantity of x plus 4 all over a times x plus 4. So we have 3 times the quantity of x plus 4 to a times the quantity of x plus 4. It should be fairly obvious that your x plus 4s will cancel out. You'll just end up in the ratio of 3 to a. That would be the ratio in simplest form would be 3 to a. So you will see algebraic ratios from time to time. It still comes up in geometry. It's still very useful. Alright, so here's some word problems. The ratio of the measure of 2 complementary angles is 4 to 5. Okay, so then we need to find the two angles. So we need to first evaluate the problem here. We have the ratio of the measure of two complementary angles is 4 to 5. Find the two angles. So what does it mean for two angles to be complementary? We know they're going to add up to 90 degrees, right? If the ratio is 4 to 5, that means initially what you're saying is you have 4 times the value of whatever angle, 4x to 5x, right? You have 4x to 5x. X is the unknown. So we'll say let x equal the angle value. We'll let x equal the angle value, the initial angle value. This could be any angle here. Let x equal the initial angle value. Well, they tell us that the ratio of two complementary angles is 4 to 5. So how you're going to solve this is take your 4x plus your 5x. That's the sum of the two angles, right? And if they're complementary, they equal 90. So you'll take 4x plus 5x, set that equal to 90, which would give you that 9x equals 90, which means x equals 10. But we're not done yet. We got the value for x, which is fine and dandy, but we have two angles that we got to find. The two angles are in the ratio 4 to 5. So 4x equals what? 4 times 10, which would equal 40. And then 5x would equal 5 times 10, which would equal 50. So the measure of the two angles ultimately is going to be 40 degrees and 50 degrees. The two angles we were looking for are going to be 40 degrees and 50 degrees. And first, if we add 40 and 50 together, you get 90. That makes sense, right? Those would be complementary angles. And 40 to 50 are both in the ratio of 4 to 5. So what you're going to do then is, if you have two angles, if it's in a ratio, you take the value of your numerator times x to the value of your denominator times x. Then you take those two numbers, you add them together, set it equal to 90 if they're complementary, solve for your x, and then plug it in for your two angles. That would be 4x to 5x. You get 40 and 50 degrees. And I got more examples like this. All right, the ratio of the measure of two supplementary angles is 11 to 4. So in this next problem, we're given that the value of two supplementary angles is 11 to 4. Find the two angles. So once again, we'll let x equal the value of an angle. That means the ratio of two supplementary angles would then be 11x to 4x, right? Now, if these two angles are supplementary, that means you're going to take 11x plus 4x. Supplementary means they add up to 180. So you'll take 11x plus 4x, which would equal 180, which would mean that 15x would have to equal 180. which would have to mean that x equals 12, which is great. We got the value for 12, but we need to now find the value of the two angles. So you're going to take 11x, which would have to equal 11 times 12, which we know to be 132. And then you'll take 4x, which would equal 4 times 12, which would equal 48. So the value of the two angles is going to be 132 degrees and then 48 degrees. Those are the value of your two angles that you're looking for, is 132 and 48. And if you add these together, you'll get 180 since they're supplementary, and if you put them in a ratio to each other, they would in fact be 11 to 4. All right. The measure of the three angles of a triangle is in the ratio of 3 to 4 to 5. So the measure of the three angles of a triangle is in the ratio of 3 to 4 to 5. Find the three angles. So yes, you actually can have a three-way ratio. So the measure of three angles of a triangle is in the ratio of 3 to 4 to 5. Find the three angles. Well, much like you would for your last problem, what you're going to do then is take the 3x, right, plus your 4x, plus your 5x, because they're in the ratio of 3 to 4 to 5, you're going to add those values together, and we know the sum of the measures of a triangle, of the interior angles of a triangle, is 180 degrees. So add the 3x plus 4x plus 5x together, set it equal to 180, since the sum of the interior angles of a triangle is 180 degrees. Which on the left side, 7 plus 5 is 12x. You would end up getting that 12x equals 180, which would then give you that x equals 15. Well, that's great that we got 15, but really your three angles are 3x, 4x, and 5x. So you'll take 3x, which would be equal to 3 times 15, which would then be equal to 45 degrees. So your first angle is 45 degrees. Take your next one, which would be 4x, which would equal 4 times 15, which we know would equal 60 degrees. So far you have a 45 degree angle, a 60 degree angle, and then of course you're going to take 5x, which would equal 5 times 15, which would equal 75 degrees. So the value of your three angles is going to be 45 degrees, 60 degrees, and then 75 degrees. And if you add these together, I promise you, you'll come up with 180 degrees. Then you divide each of these by a common 15, you'll get the ratio of 3 to 4 to 5. So the three angles are 45 degrees, 60 degrees, and 75 degrees. Oh, this is another good one. This is a very good one we're about to do. the measure of the acute angles of a right triangle are in the ratio. What is that ratio? Are in the ratio of 5 to 7. They're in the ratio of 5 to 7. Find the two angles. So this is a good one because this brings in a very important theorem that we had earlier in the course. So the problem is the measure of the acute angles of a right triangle are in the ratio 5 to 7. Find the two angles. Well, I think it's obvious here that we're going to start out with 5x plus 7x is equal to something. What do we know based on the one theorem we learned? That the acute angles of a right triangle are complementary, meaning that the acute angles of a right triangle add up to 90 degrees. So you would take your 5x plus 7x, set them equal to 90. So this is where algebra and geometry come together. It's important to remember past theorems. Well, what's 5x plus 7x? That's simply going to be 12x. You'll have 12x equals 90, which means x would have to equal 90 over 12, or we divide them each by 6, it'd be equal to 15 over 2. X is equal to 15 over 2, this would reduce to 15 over 2 is equal to 7.5. Yes, you will get decimals sometimes. You will totally have that. Well, the two angles are 5x and 7x. So 5x would equal 5 times 7.5, which would have to equal 37.5 degrees. So your first angle is 37.5 degrees. Then go ahead and take your 7x, which would equal 7 times 7.5, 56, 49. Halfway between those would be what? 56 and 49, so that'd be 3.5, that'd be 52.5. So yeah, so in this case you would end up getting 52.5 for your second angle. So the two angles you are looking for have measures of 37.5 degrees and 52.5 degrees. You will get decimal answers. That is perfectly normal. And I guarantee you, if you take 37.5 and 52.5, you'll actually come up with 90. And then if you set them in a ratio to each other, you would in fact get 5 to 7. So that was a good problem bringing in a past theorem. I got two more problems, then we're done. Let's see. The measures of the angles of an isosceles triangle are in the ratio 3 to 3 to 2. Find the three angles. Okay. So this problem tells us here that the measures of the angles of an isosceles triangle are in the ratio of 3 to 3 to 2. Find the three triangles. Well, obviously the 3 to 3 would be the same because in an isosceles triangle, two of the angles are congruent to each other, right? So take your 3x plus your 3x plus 2x, and we know the sum of the measures of the interior angles of a triangle are 180, or is 180, I should say. So 3x plus 3x is 6x plus 2x, that's 8x, would happen to equal 180. Which would have to mean that x equals 180 over 8, which would have to equal, let's see, that would have to be 45 over 2. If you divide both the numerator and denominator by 4, that's 45 over 2, which turns out to be 22.5. So x has a value of 22.5, but now we need to take and find the values of the angles. So you'll take 3 times 22.5, which would be equal to what? Well, 2 times 22.5 is 45, plus another 22.5. That's going to be 67.5. So you would have 67.5 degrees, and actually this occurs twice because you have an isosceles angle. You would have two 67.5 degrees angles. Then you'll just take 2 times 22.5, which should totally give you 45 degrees. So the value of the three angles you're looking for are going to be 67.5 degrees, 67.5 degrees, and then 45 degrees. And then if you add these together, you should totally come up with 180, because 67.5 plus 67.5, so what would that be? 136, 135. Yes, you would get 135 plus 45 would give you 180. So those are the value of your three angles. Got one more problem for today, and it's kind of a big one. It's the same type of problem, but, well, you'll see here in a minute. This brings back a really good theorem. Okay. The measures of the angles of a hexagon are in the ratio. Here, this is going to be a fun one because there's 6 angles since it's a hexagon. 4 to 5 to 5 to 8 to 9 to 9. So we have a 6-way ratio this time. find the 6 angles. So we need to find the 6 angles of the hexagon. Well, there is a very important formula we learned earlier in the course. Obviously, the ratio of these angles is referring to the sum of the measures of the interior angles of a hexagon. A hexagon has how many sides? It has 6 sides. Remember the formula? We have the number of sides minus 2 times 180 degrees. That equals the sum of the interior angles, right? Well, in this case, the number of sides we have is going to be what? 6. Then you'll put minus 2 times 180 degrees. Well, what is 6 minus 2? That's 4. So that's going to equal 4 times 180 degrees. Well, 4 times 180 is equal to what? 720 degrees. So the sum of the interior angles of a hexagon is equal to 720 degrees. So what we have to do now is take all these 6 angles, set them, we got to add them together, set that total equal to 720. So this will become 4x plus 5x plus another 5x plus 8x plus 9x plus yet another 9x for all 6 angles. Set that equal to 720. Yikes, that's a big one, isn't it? Then we can come up with a value for x. So 4 plus 5 is 9, plus 5 is 14, plus 8 is 22, plus 9 is 31, plus 9 is 40. So therefore you'll have that 40x is equal to 720. Which then both sides do in fact divide by 40. X would be equal to what? What is 720 divided by 40? Well, 720 divided by 4 is 180, so it'd be 18. So the value of x itself is 18, but we need to find the value of the 6 angles, so you're going to take each of these 4x, 5x, 8x, and 9x's, do 18 times those x's. So let's take 4 times 18. What does that equal? That equals 72 degrees. So you have one 72 degree angle. Alright, let's take 5x. Whoops. Let's take 5 times 18. Well, 5 times 18 equals 90 degrees. And you have two 5x's, so you're actually going to have 90 degrees twice. So far you have a 72 degree angle, two 90 degree angles. Then you're going to take 8 times 18, which is going to be equal to 144 degrees. And then last but not least, you'll take 9 times 18, which would have to be equal to 162 degrees. And then you would actually have 162 degrees twice, since you have two of the 9x's. So the value of the 6 angles you would be looking for is 72 degrees, 90 degrees, 90 degrees, 144 degrees, 162 degrees, and then another 162 degrees. So those are all 6 angle measures of the hexagon in question. You end up coming in with 72 degrees, then two 90 degree angles, then 144 degrees, and then two 162 degree angles. If you add all these together, you'll get 720, and if you find the common ratio, you'll all find that they are in the common ratio of 4 to 5 to 5 to 8 to 9 to 9. Yikes. But that's how you would solve those type of problems. So that's really it for ratios. The very next lesson, we're going to get into properties of proportions. So I hope everybody has a great night and take care.